Our understanding of the atom has changed considerably over time, from Democritus with his atomos of different shapes and sizes, to Dalton with his solid sphere, to Thomson and his plum pudding, and beyond. Today we are going to focus on Niels Bohr's model of the atom, how the electrons arrange themselves around the nucleus, and how this connects to the periodic table of elements. Bohr's model of the atom is known as the planetary model, because it shows the electrons orbiting the nucleus of the atom like planets around the sun. While science has shown us that electron motion is in fact much more complex than Bohr's model suggests, it is still useful for understanding basic electron arrangement. When drawing a Bohr model of an atom, you must first start off with a nucleus. In that nucleus, you write the number of protons and the number of neutrons in the atom. Remember, the number of protons tells you which element it is. Next, you must determine the number of electrons. For a neutral atom, not an ion, the number of electrons is equal to the number of protons. The one thing that Bohr discovered was that electrons are arranged in specific energy levels, also called electron shells. Each electron shell has a specific number of electrons it can hold. The shells farther away from the nucleus can hold more electrons, and the ones closer to the nucleus can hold fewer electrons. When adding electrons to the atom drawing, you must add electrons to the lowest energy level first, the one closest to the nucleus, and fill a level entirely before adding to the next one. The electron shells can hold 2 electrons in the first level, 8 in the second, and up to 18 in the third. However, it's considered full at 8. One thing to note is that after argon, Bohr's model of the atom becomes less helpful, as that one is when electrons get more complicated. So we're only going to be using the Bohr model of the atom to talk about elements 1 through 18. Let's practice drawing a Bohr model of an atom using the element nitrogen. The first step is going to be determining the number of protons and neutrons. Nitrogen has an atomic number of 7, meaning it has 7 protons, and the total number of particles in the nucleus is 14. That's its weight, meaning it has 7 protons and therefore 7 neutrons in the nucleus. Next, you're going to determine how many electrons there are. Now, nitrogen atom means that it is neutral, meaning it has no charge. So that means the 7 protons, 7 positive protons, are equally balanced with 7 negative electrons. Finally, we need to add these electrons to our drawing. We are going to add them into the electron shells. The first shell holds 2 electrons, so we add the first 2 electrons to that first shell. That leaves us with 5 electrons remaining to go into our second electron shell. And voila, the nitrogen atom. Now let's take a look at how we can use the periodic table to tell us more about the arrangement of electrons. Here is the periodic table. It was originally arranged by atomic weight and grouped into columns by properties and characteristics. We now know, however, that it has all of the elements arranged by atomic number, i.e. number of protons, and that the common properties are actually a result of electrons. Atoms in the same column have the same number of electrons in their outermost energy shell, also known as the valence shell and valence electrons. And we can use the periodic table to tell us exactly how the particles are arranged in an atom, how the protons are, and how the electrons are. Let's take aluminum as an example. The atomic number of aluminum is 13, which means that it has 13 protons. The atomic weight of aluminum is 26.98, which is a weighted average based on how common the isotopes of aluminum are. That number, of course, rounds to 27. If there are 13 protons, that means that there are 14 neutrons in the nucleus. So now on to electrons. Aluminum is in the 3rd row of the periodic table, meaning that it is 3 electron shells. Counting from the left, it is 3rd in the 3rd row. meaning that it has 3 electron shells. The inner 2 are full, and the third one has 3 electrons to finish it off. It's now time to try out drawing Bohr models for yourself. Give it a shot.